Howdy, I want to walk y'all through RASAero and how we can use it to get our drag coefficient versus velocity, so that when we're doing our own flight models, we can have a table of velocity versus drag coefficients to look up, so we can get a more accurate model. First of all, you need to build your rocket, and this is of course the most important part because crap in equals crap out, but we are going to be doing crap in for today. We're going to have a diameter of our nose cone, we're going to have a length, and we're going to have a tip radius, and we're going to add it in. And that looks alright to me. We're going to keep going. I'm going to give you just a bunch of things. So we have a transition. This is going to be 1 inch, if you remember from our open rocket. Of course, you should be using your open rocket as a model for a completed open rocket model so that you can put it into RASAero so you can get more accurate CD data. I want my rear diameter to be 6 inches. But because I'm stupid, we need everything to be 5.5 inches. Yeah. Okay. And now we have our transition here. I want to now add another body tube. This one's going to be our 138-inch length tube for our tank. I'm going to add another transition, which is so short, but it is the transition from aluminum to carbon fiber. And because it's basically instant, I'm having the length be very small. But I think once we overwrap the tank, we're going to be at like 6.125 inches. But now I can add a 6.125 inch carbon fiber wrapped aft end. And we're going to add that. And so we're going to go back here, because we do have fins. We have 3 fins. And you can make your fins now. So I'm going to say my root is 10. And change this until it looks right, I think is how we should be doing this. I think this is upside down though, so I need the base way over here. So make sure to just put inputs for everything. Let's call that our fin for now. We'll have an aerofoil, and that's going to be rounded because I think we're going to end up 3D printing something for that. Okay, and as you can see, it's completely off the end of the thing. So let's look at our fins again. Distance, they're 10 inches long, so I think we need to add 10 inches back. Ah, true. So now, let's say this is the shape of your rocket, which it's not, but this is the shape of your rocket. You don't even need to add a motor for this. You're just going to look at a aero plot. So we're looking at the aero plot, and it already gives it to you. It's your CD versus your Mach number, and it gives you your Mach number versus your coefficient of drag. If you do want to have the distinction between power on and power off, then you're going to need a motor. But to explain the difference between y'all, when it is on, that means you have a plume of smoke going off the back end of your rocket. So when we're burning, we likely have a lower coefficient of drag than if we are not burning, because it's more sharp. It's more of a sharp cutoff when you stop burning than if you are burning. So you're more aerodynamic when you have a plume of smoke following behind you. But now you can have this table. We're likely not going any faster than Mach 2 or something. Probably not even hitting that. So the main importance is in the initial section. So export that, and you can put it into your flight model.